Certainly a pleasure to be here. I'm going to talk about JavaScript. It is an exciting language. It's a language that's been around for quite a long time. I'm going to dissect a few things in the language, take a look at some of the things. We'll do some coding here and take a look at a few things. Best time to ask a question is when you have it. And if you do ask a question, please wave your hands. For some reason, it's easier to hear you when I see you. So if I know you where you are, it becomes easy to hear. So let's talk a little bit about JavaScript. Let's start by talking about what's really wrong about JavaScript. And then I'll talk a little bit about what's good about it. And then I'll go into some of the things we have to be careful with in JavaScript. And then we'll talk about writing functions and what are good ways to write functions. We'll talk about higher order functions. We'll talk about other few problems. And then we'll talk about creating classes and then conclude with one of the nicest features of JavaScript, which is the prototypal inheritance. So let's start with what are the problems with JavaScript. One of the first problems with JavaScript is inconsistencies. Different browsers tend to deal with this differently, so it ends up causing problems and confusion quite often to programmers. The next problem with JavaScript is, what a terrible name for a language. What is JavaScript? The word Java has to do with anything. I mean, would you do this to your kids? Would you name them after a neighborhood popular kid? And how would your kid grow up, right? So that's kind of terrible, right? To give a name like JavaScript to a language because Java was getting popular. In fact, somebody said this the other day, which is kind of funny. In the beginning, they wanted to associate with Java because it was cool. Now they are trying not to associate with the word Java. So it's important not to name languages like that, right? It's a language that's largely misunderstood. Oftentimes, it's really confusing for programmers. But one of the biggest problems with JavaScript, how did you learn JavaScript? Honestly, I'm sure the way I learned JavaScript is exactly how you learned it. How did you learn it? By looking at code on the web and copying and pasting. Come on, tell me, is that what you did? Absolutely, right? And you know what? Most of the code on the web sucks. So no wonder the entire JavaScript code sucks. If we had looked at good code and copied and pasted, then it would look really better, isn't it? So it's important to really learn a good way to write JavaScript. Now, if you want to look for a guy who knows how to write good JavaScript, his name is called Douglas Crockford. And he wrote this fantastic tool called JSLint. I'll talk a little bit about it towards the end of the talk. And Douglas Crockford also wrote a book called JavaScript, The Good Parts. It's actually a bit of a frustrating book to read because the book is filled with all the bad things that the language does. And then there's a small part of the book where he says, here's how you really use the language in the right way. So you kind of have to really focus on the good parts he talks about. And if you focus on those good parts, you can actually write good code with it. So talking about good things, let's see what is good about JavaScript. What are the things we could use? JavaScript is a language that's quite powerful. In fact, I would argue it is probably a little too powerful for a language. That's one of the reasons why it becomes really hard to work with it. JavaScript is dynamically typed, but is also weakly typed, meaning it doesn't enforce type information, but the dynamic typing actually becomes extremely flexible and powerful. In fact, I'll show an example of the dynamic typed nature of this and how it offers flexibility in one of the talks I give later today on test driving JavaScript, and we will see how we can make use of this very effectively when it comes to writing Java code, or JavaScript code rather. It's very flexible. JavaScript provides functional style of programming. Now, by no means I want to call JavaScript as a functional programming language. In fact, most people would argue it's dysfunctional in a lot of ways, right? Because it gives such a terrible time to programmers to use. But there's really good parts of JavaScript. It gives us a functional style of coding. Now, what does it mean by functional style? Well, when you want to look at a functional style language, there are two components to this. One is the purity of functions, where there are no side effects and immutability is preserved. The other aspect of functional style of programming is where you have higher order functions, meaning you can create functions within functions, you can pass functions to functions, and you can return function from functions. And that's the part that JavaScript supports, is that you have higher order functions that you could actually use. But to me, one of the most exciting parts of JavaScript is that it's a prototypal language. What does that mean? What that means is JavaScript supports objects, but not like the way we are used to using objects in traditional object-oriented languages. JavaScript supports inheritance, but not in the way we are used to in traditional object-oriented languages. And I would argue it actually supports inheritance in a much more flexible way if we can actually get used to it. So those are some of the nice things, and we'll take a look at some of those things along the way here as we go through. But let's start with some ground rules first of all. One of the very first rules in JavaScript is they will tell you that it is optional to use semicolon. But if you don't, it'll hurt you in the wrong place. So it's important to remember to put semicolons at the proper places. Let's take a look at an example here just to kind of begin with. I'm going to start writing a function here. So I'm going to write a function. And in programming sessions, it is mandatory to start a function with the name foo. So I kind of took care of that checklist, right? So we have a function foo. And this function basically is taking a parameter here. Let's just say a number n I want to pass. And I'm going to say if n is greater than 5, I want to return. Now, I'm getting more and more used to languages where return is optional and semicolon is optional. So this is actually enormous effort for me to remember to put these two. So remind me along the way as I'm coding here, because I will forget to put return and I'll forget to put semicolons because I've gotten so used to omitting those things. And of course, later on today, I will talk about CoffeeScript, where you will not put return. So thank God we're back to really writing code the right way in CoffeeScript. So return basically n times 2, let's say. And in this case, I want to return a number n and then times 2. And what do I want to do? If it is else, I want to simply return the number n itself. See, there you go. I forgot to return as I'm speaking, right? OK, let's call foo. And I'm going to send a 2 as the value. So what do I want to do here? I want to print out what this is returning. If I send 2, what's going to happen? Well, 2 is less than 5, certainly. And oops, that blew up really bad. That doesn't really look good. So what did I do wrong here already? So I'm calling. Let's see where the error was. Lower this a little bit and take a look at it. Anybody sees it? Else. So I need to, again, things that you have to kind of get used to. It becomes really hard when you have to really follow ceremony and you work really hard to get out of it. All right. So right there. But let's go a little further with this. And now I'm going to say call foo. And I'm going to send, let's say, a 6. Well, of course, 6 is greater than 5. So what do you want it to do? You want it to return 12, isn't it? When you run it, oh, what happened? It gave us an undefined. So what's going on here? Well, what JavaScript did is it said, remember semicolon is optional. And then it said, let me help you. And it put a semicolon where you don't expect it. So it actually is returning nothing. And as a result, you got an undefined. And it can really get confusing in these regard. So when you're really splitting the lines, you got to be careful where you're splitting it. Otherwise, it can lead to some surprises along the way. And you have to be a bit careful about this. So little things like this can come back and haunt us. Be careful. Now, in JavaScript, you better define variables before you use them. You ask, what if I don't? Well, let's find out what happens if you don't. So here's the function foo. And I'm going to define a variable here. So var, I'll call it local1. It's not local because I called it so, but I've just put the word var in front of it. So I'm going to display the local variable here. So the local1 is being displayed here. So we start with that. So I'm going to call the function foo. And as you can see, it's displaying the local variable's value. Now, outside of this function, after I call it, if I try to display the local variable one more time, I get an error because that variable doesn't exist. Makes sense, right? Now, if I go into this function, and if I say here, g equals 4, and I'm going to display the value. So I'm going to print out the value. So as you can see, it's going to print the value 4. But I'm going to come out of this function, and I'm going to print that value. And notice it showed up here too. What's going on here? If you forget to put the word var, guess what it does? It makes the variable global. And you know why it does that? Because that's the worst thing that you could do in programming. So as a result, it said, let me hurt you so you will never do this again. So as a result, JavaScript has a weird way of teaching us, right? So, and as a result, in this case, you always have to put var in front of this. Again, later on we'll learn today that CoffeeScript kind of eliminates all that and makes it much easier to work with. So always remember to put var in front of variables to make sure you define the variable scope properly. Now, another thing to remember in JavaScript is if you have a block of code that you are going to define. So right here, I'm going to define a block of code. And within here, I say local2 equals, let's say, 5. I'm going to display the variable local2, as you can see here. So it is displaying 5. But what if I come down outside of this block of code and display local2 one more time? Well, if you're programmed in language like Java or C++ or C#, you would say, well, that shouldn't work over there because you're outside the scope of that inner block of code. Well, unfortunately, though, in JavaScript, there is really no block scope. And as a result, if you define a variable within a block, you really are defining the variable up in the top of the function. In fact, when you are writing this code, what JavaScript is doing is, before you come to line number 7, it has already defined the variable up here. So you could actually use it up here, and you could ask him what is local2, for example. And of course, because you didn't give a value to it, it is undefined at this point, but it is still there in memory. So in other words, in JavaScript, all the variables come to life in the very beginning of functions. So remember how we used to program. If you've been programming for more than about 15 years, you remember you would define all your variables in the top of the functions, and then you would continue to use them. And then when C++ came along, we kind of departed from that, and then we said, hey, let's go ahead and have inner scope. Now we are saying in JavaScript, don't do that, right? Go back and define all your variables at the top. Now you may say, wait a minute, that is not a good idea, because if I define all the variables at the very top, then I don't know what those variables are when I have a long function. I will tell you that's very easy to fix. Don't write long functions, right? So that is a way to take care of that, and so you don't have to worry about it. So define your variables in the top, and then you're done with it. So these are some of the things you have to be careful with when it comes to JavaScript. How do you write functions? There are about 2.5. A function, maybe you would start like function, foo, and then it takes a variable name, and then you may say, for example, provided, and then I would say n. You can call the function foo and send a value to it. So this is a traditional way of writing functions. I'm sure you have seen your share of writing functions this way. It does require you to spell properly. There we go. So now I recommend that you don't write functions this way. I mean, you may protest, this is the way you see most of the code, but we agreed in the beginning of the session that most of the code we see sucks already, so no point arguing about it. A better way to write the function would be to write a variable equals function, and then you want to be able to call that in here, and then you could say you called with, and then we're going to display the variable n. So what is the difference here? So if I call the function foo1 here, it works almost the same way, but the difference is we created a variable called foo1, and we assigned it to a function. This does good in several different ways once you get used to it. The nice thing about this is, once you define a function, you realize that quite a number of times in JavaScript, you write event handler code. And you register these event handlers to various things like buttons and checkboxes and so on. So you end up writing these anonymous functions, and then you pass them around to these objects. And when you write these anonymous functions, the syntax of that is going to be very much close to what you see on line number 5. So that kind of consistency helps quite a bit. This also tells us on line number 5 that a function is really an object that you are assigning to a variable. So that kind of notion also gets into our head, and that's a good thing to have in mind as well as we program with this. Now I promised that there's 2.5 ways to do it. A third way to write functions is going to be to say function, and then you say foo2, and you define the function this. This is an example where people who love redundancy write code like this, right? That's why I said there's 2.5 ways to write code. Well, actually, this can be useful in some ways, especially if you want to kind of refer back to functions. But again, this is kind of unnatural, and it's better to avoid it as much as you can, unless you have a real good reason to write functions like this. So we looked at a couple of different ways to write functions and how to use it. Let's talk a little bit about arguments to functions and how we would use arguments to functions. All right, that's kind of not responding properly there. So, okay, how do we write arguments to functions? Now, here comes a shocker in JavaScript. JavaScript is extremely flexible. And as a result, you kind of have to know a little bit about how JavaScript works. So let's say we have a function here called max. So max equals function a comma b. And I'm going to say if a is greater than b, return a, else return b, right? So I'm going to say return a. And if it is not, I'm going to simply return b. So I'm going to say return b. I don't even have to have an else here, right? So let's go ahead and call this. And I'm going to call it with max, let's say 1 and 2 as 2 values. Let's also call this one more time. And we'll call this max with 3 and 1, just to swap the parameters and make sure it is actually working. Cool. Now what's going to happen if you call this one with max and only send 3 to it? What do you think is going to happen? If you're programmed in languages like C, C++, Java, it would have given you an error at this point. But JavaScript treats you like a guest. If you're a guest in somebody's house and you leave a cup of mug in some place, they don't scream at you, right? They kind of be quiet and they quietly deal with it. So in JavaScript, you're treated like a guest. It will never complain to you. It'll quietly misbehave, but that's a different story, right? But it never complains to you. So as a result, when you run this code, let's see what's going to happen. It just gave us an undefined. Now, why did it give us an undefined? Because you sent him an A and a B, and during the comparison, he kind of ended up messing with things. He quite doesn't know what to do. Now, you could go a little further with this. You could even call, let's make this a little bit more fun. I'm going to say, call this max, but this time with 1 comma 2 comma 3. So you're given an additional parameter. Guess what? JavaScript will still not complain to you. It simply says, that's okay, sweetie, you just gave me more than what I needed. That's all right, what's the big deal, right? So it doesn't complain to you. Now this kind of makes you wonder, what in the world is JavaScript really doing? So this is something you have to kind of get in terms with it. So think about this as, you have a, kind of a plate in front of you, and the argument list that's given to you is like that. And it can have any number of items on it. And you decided to name a few items. And so unlike other languages where you define a parameter list, you really are not defining a parameter list in JavaScript at all. You never define a parameter list. The definition of the parameter list comes from the caller and not the person writing the function. So then what are you doing as a writer of a function? You're just giving names to a few of the parameters in the parameter list. You just chose to give a name for the first 2 parameters in this example, and you're not giving names for the other ones. Once we realize that, notice what I can do now. I can pretty much remove these parameters from here in the first place. After all, if it is not a parameter list, why pretend to giving that? And now I can actually implement this code by, let's pretend that we only have 2 parameters for now. And I'm going to go out and reach out to something called arguments. And arguments is, let's start with this actually. So I'm going to print out here arguments. Let's start with that. So when I print out arguments, and let's just only call max with 1 and 2 right now. And notice it is printing arguments. And it tells me that it received 2 arguments in this case. If I again call this function, but this time with max of 1 comma 3 comma 4, you can see that it has 3 arguments. Given this now, we can write the code a little differently. We could say var large equals arguments 0 as the first element. We could say for I in equal to 0, right, the beginning value, I less than arguments dot length, and I plus plus. And then we could navigate and say, if the arguments of I, the value I here, is greater than the large value, then the large value equals the arguments of I. And then, of course, when we are done with the whole thing, we can simply return the large value back to the caller. So now we can print out this value that we have on hand and we can see that it's able to receive and process 3 parameters or 2 parameters or how many ever number of parameters we send. So in other words, arguments is the collection of parameters, and the symbolic names that you give in the parameter list are just kind of symbolic names. That's all it is. So this is something we got to kind of get used to, this particular notion in writing code, and that is basically what JavaScript provides for us. Now, the other thing I want to talk about is about this variable. Within every function, there is a this object associated with it. This really helps in dealing with object-orientedness. We'll see this later on. And you can set the value of this. And when you call a function, you can also call functions using a couple of different options. One is called call, another is called apply. Let me quickly show you an example of how these things will work. So to call the function max, for example, so we will know that you're calling the function max. I will say here max called. So you could call the function like this. So you could say 1 and 2. We saw this example before. So it says max called. Another way to do this is to say max.apply. This word apply comes from the functional style of programming. And then you could specify 1 and 2 as the parameters that you want to pass. And you can see that it's calling the max function also one more time. And apply becomes really useful in cases where you want to call a function. But why would you want to do this? Now imagine for a minute. When I called max, I sent 1, 2 as discrete values in the call. But if you're in a web application, most likely the parameters that you want are coming from a query string. And when it's coming from a query string, it's much easier to collect it in an array and use these parameters in an array itself. Now, if you have to take this array and split this into the number of parameters that you have to pass, that's a bit of an ugly code you have to write, isn't it? Now, you don't have to do that. You simply call the apply method and send this array to it, and he's more than happy to receive it and do the dispatching of these parameters to it, so that can save you a little bit of effort. In a similar way, the call method also works, but the difference is when you say max and you call the call method, you can then send the discrete parameters if you want to. And if you wonder what this null is, that's a binding of the current object or the context object, which is useful in object-oriented programming techniques, but I will kind of avoid that for lack of time here. I won't go into that detail, which I normally like to do. So given all this, we can also deal with higher order functions. What does that mean? You can actually write functions that accept functions, and this becomes a lot easier to work with in a functional style of coding. This you've probably heard about, and I'm sure you have used, strategy pattern. Now, a strategy pattern is where your code is going to use a certain computational algorithm or strategy, and the rest of the code depends on it. So it will call into a pointer and receive the object it wants to and use it. Go ahead, please.
Function max, actually. I just noticed that the argument attribute that we are seeing here, it is being used as an array.
Correct.
The actual reality is argument is supposed to be an object which we already saw it. When we did a console log, we saw it that argument is being printed as a JSON object. Mm-hmm. Right. So, I mean, we are directly using it as array. Is that a good style or what?
This is another unfortunate thing. In JavaScript, arguments is actually not an array. It is array want to be.
True.
And so it kind of gives you all other kinds of problems. So we kind of will avoid that.
Yeah, so should we be converting it to array first and then we using it, or we directly use it?
No, you should convert your code to CoffeeScript and deal with it.
Okay.
That's messy. That's why there's really no good answer to it. And later on when I talk about CoffeeScript, you will see how beautifully they use a splat to completely resolve it. So that's kind of, CoffeeScript is JavaScript done right. Yeah, that's more ceremony you have to work with, right? And once you know it, you know how to code it. But there's no reason to even get to that part of town, right? You can completely avoid it. So that is basically, so higher order functions. What do higher order functions do? Higher order functions basically are function objects that you can pass to other objects and use very nicely. So for example, if I want to total values, so I say total values, and this is going to take numbers as parameters. And within this function, what am I going to do? I'm going to say, let's say this is the function. And in this case, I'm going to just total these values. So we could say total equals 0. I want to return the total when I'm done. And in between, I'm going to take these values. So we could say I equals 0, I less than numbers dot length. And then I'm going to simply total each of these values. So we could say total plus equals numbers, and then we could get the values in the collection and use it. So if I define nums equals, let's say, a bunch of values, let's just stick with 4 values here, and I want to call into this. So I will call into over here, let's say total values, and this is going to be totaling these values, if I know how to type, there we go. And this is going to be nums, and this is going to total all the values given to it. But what if I really want to be selective? I want to only select a certain values and use it. What we could do here is we could specify another additional parameter called a selector. And in this code, I could say if the selector on the numbers I was happy with the value selected, then and only then do the total. So now I can come in here and say comma, and I still want to total all the values in this example. So I define a function here, which is going to take a value n, and it simply returns a true value as a result itself. So in this case, the total value is going to come in here. Let's see what I'm doing wrong. Do you see what the error is? What line number? 5. So I've got a parentheses here. There we go, thank you. So there it is, the total for all. But we could quickly use this, right? And we can say total values on the nums, and then we can specify, in this case, a function. This time I want to check only that these are even numbers, for example. So the modulus of that equals to 0, and then we can ask him if it is an even number and only process even numbers and total of even numbers. So this is a higher order function. It becomes very easy. One of the beauties of this is you can save this away into a separate function as well, is even as a function. And then you can say a var is even equals that function that we just saved away, and then we can then use this in this code, and so that way we can reuse those functions as well, and then that becomes pretty natural to use it. And one small problem I want to mention before we move on. I want to compare two values. So I'm going to say here, given a function, let's say we have a function foo, and I want to compare a value being sent to it. So some value being given to it. I want to print out if n is equal to 2 over here, right? 2.0. So I'm going to call this function, and it's going to tell me true or false. So I call foo, and I send him a 2.0, right? That's pretty logical. It is checking for 2.0, I'm sending it. It said true, so we're happy with it. But now I call foo one more time, but this time I'm sending him a string of values. And notice he says true one more time. What's happening? Because a double equals, again, is treating you as a guest. It says, well, let me bend over my back and convert these and do the checking. But there are times when you say, thank you for being polite, but be direct, right? So that really helps to have a very deterministic comparison. So how do you do that in JavaScript? Well, JavaScript has this wonderful function. I'm sure you will love this function. It is called triple equals. And isn't that beautiful? So you use triple equals to do the comparison. Now, why is triple equals better than 2 equals? Because you got more equals in it, isn't it? And I had a guy who said, can I use 4 of them? Let's not go there, right? That's not going to help. So, in other words, in JavaScript, please don't use double equals. You're going to very rarely use double equals. Most of the time, you're going to use triple equals. And it is even more fun when you have to compare it for not equals. Because now you put a bang equal, right? Isn't that beautiful to the eyes, right? And so this is one of the things that CoffeeScript again eliminates. In CoffeeScript, you don't have this mess. They completely removed the 2 equals, and 2 equals in JavaScript, 2 equals in CoffeeScript is actually 3 equals in JavaScript itself. So it's important to use 3 equals when you're using JavaScript itself. Now, having talked about all of this, let's talk about functions. Functions are objects, and objects are functions. You say, well, I want to create an object and use it. How do I go about creating objects and using it? And JavaScript really doesn't burden you. You want to create an object, you create an object. In Java, C++, C#, most of these languages, ignore C# for just a moment. There is a little flexibility there. But how do you really create an object? Stop. You first have to create a class before you can create an object, right? The language imposes that on you. It's a burden you have to carry with you. Not so in the case of JavaScript. So notice what I'm going to do here. I'm going to write a function that says create function. So create person. So I'm going to say this is create person. And this is going to be a function, and it's probably going to take some data. We don't have to worry about it. And I'm going to simply say return, and in this case, I'm just going to create an object. So I'm going to say first, and this is going to be, let's say, Scott over here, and then this is going to be last, and this is going to be, let's say, Davis over here. So we are returning just an object in this case. And we could then call this function, or let me simplify this, and simply say person equals, and just create a first, and this is going to be Scott, and this is going to be last, and this is going to be Davis. And now you can use it. So I can simply print out the person that we got on hand. So what does it say? Notice how beautifully it says the person object we created. You could even say person.first and get to the particular property of this object itself. So that's how easy it is to use it. What kind of object is this? Well, this is in favorite terms called as the JSON object, or with accent you can call it JSON object. That's kind of silly, but I usually like to call it JSON. And so JSON object is basically a very lightweight object. It stands for JavaScript object notation. And JavaScript object notation really is a subset of the JavaScript language itself, and you're creating. But this is a full-blown, respectable object. And for example, you can go to this object, and not only can you ask this object to have properties, you can also ask this object to do stuff for you. For example, I'm going to say sing over here. Oh, wait, that was Scott. Never mind. We could say code over here. That's much safer when it comes to Scott. So we could say, in this case, a function I'm going to implement, and this is going to implement a piece of code, and he's going to be coding, and then bug, and then code. And he kind of does it very effectively, right? So you can then come back to Scott and say person.code, and you can invoke that function. Oops, already it's broken. This is going to be just a function, so you say function, and then you specify what the function is. After all, that's what you're trying to do, isn't it? So notice how you can call these functions, and this is basically a function you're assigning to this object, and then you can go about calling it. Did it work? Let's see what happened here. So I'm calling the code function on it. So right there, coding. So you can see that you're able to have functions, and properties can be functions as well. So we created an object as a lightweight object, and it feels light, isn't it? Right? You're not putting class and creating all of that. We say, okay, that's cool. I like this object. What can I do with it? Here's the beauty. Once you create this lightweight JSON object, you can pass it around on the web. On the other side, it could be a Grails application or a Groovy code or a Ruby code, what have you, and that can just receive the JSON object, and most of these have JSON parsers that can parse and recreate the object on the other side, and you can use it. So that becomes very useful to work with. So having done all of this, how would we go about using a class itself if we want to create it? So how do you create a class? Let me create a class for you. So var car equals function, and right there, congratulations, you created a class. You say, hey, wait a second. We saw you create functions exactly the same way. Are you cheating? No, promise. I created a class just now. How? Pay attention. Did you notice this is uppercase C here? Right? Does it make a difference? No. But it feels good. Right? If you do that, JavaScript compiler laughs at you under the covers. It says, these stupid humans, right? They kind of get excited about a lot of stuff. But it is just a convention, that's all. So when you code, you know the intent here is not to create a function, but to create a class. But a class is a function is a class. Everything is kind of meshed together in JavaScript. Whether you treat it as a class or a function is entirely up to you. So what does this mean then? Now that we have created a function, you can, if you do car, and I noted, thank you. If you call the function, then you're really not just using the class object of this. You simply are just calling a function. And there's nothing wrong with doing it. But the real excitement comes in if you are going to create an instance of it. So you say car1 equals new car, and now you have an instance of this. If you're curious about this, go to the car1 and say type of car, and also go to the car1 and ask him type of car1 and see what it tells you, and notice that one was a function and the other one is an object under the covers. So what does the new car really do? What the new car really does is it creates a instance of that function and attaches to a prototypal instance. Hey, what in the world is a prototypal instance? Well, we'll get to that in a minute. But I want the year for the car, actually. So I'm going to say year is the value given. But I cannot just, where do I store the year? So I say this dot year equals year to store it. And now I can come down here and say car1 dot year to get the access to the car itself. We can get the value of the year if we send to it. So in this case, I'm going to say 2012 is the year. And you can see the object has a year property. Similarly, we can define a drive method. And in this case, I'm going to say distance for driving. And we will say, driving distance. So we could say driving distance, and then we'll print the distance we are driving. And in this case, the distance, dist, is the variable I called. So let's go ahead and call this. So car1.drive, and tell him to drive. And you can see that in this case, the drive function, did I just write groovy along the way? Don't tell anybody I did. Okay, so drive equals function. That's what happens when you code in 7 languages. So right there, I'm going to call this function. So a function is taking a distance. And in this case, this is just a property of the object itself that I'm defining. So this dot drive is what you should use to set it. So you can see that it's driving the distance and you're able to set it. But what's happening in this case is that when you create an object, what's happening? So this is exactly what's happening in the case of JavaScript. So JavaScript objects are like me. Notice that I'm walking around with a backpack right now, isn't it? Because I'm not going to carry everything with me. So you come to me and say, can I have $1, please? I'll give you $1. I have it in my wallet. But if you ask me, can I have €1, please? Well, I don't have euros in my pocket, but I do have them in my backpack. And I'll reach into my backpack and pull it out for you and give it to you. That's exactly what JavaScript objects do, is they all carry a backpack. That's known as a prototypal instance. Now, what's really weird about this is that objects have prototypes, but prototypes themselves have prototypes. And this can go on until for a long time. And eventually the last guy also has a prototype, which is called the object prototype, which is a curly, open curly end, which is an empty JSON object. And that guy doesn't have another prototype to it. Now, what's going to happen? One of the things we need to understand about prototypes is every object has a prototype. However, in order to understand how the prototype works, Scott, would you be my prototype? Absolutely. Thank you for your help. So you come to me and say, hey, Venkat, can I borrow $2 from you? And I'm going to be nice to you. I'm going to give you $2. And what's your name, sir? Venkat. Anybody who's not a Venkat here? Okay, what's your name? Nitish. Nitish? Nitish. Okay. Sorry, Venkat. So Nitish wants $2 from me, right? So what do? I give him $2. Why? Because I have $2 with me. Well, a few minutes goes by. He comes to me and says, can I have 10 rupees from you? Well, it so turns out I don't have rupees, but I know Scott has some rupees with him. So I go to him and I tell him, Nitish, sure you can have 10 rupees, right? Because I'm not going to say no to him. Such a nice guy. And I say yes to him. But what do I do quietly? I quietly go to Scott and say, can I have 10 rupees, please? So he has given me 10 rupees, and I go back and give it to Nitish. Who gets the good name here? Me, of course. But it gets only better, right? So where did I go to get the 10 rupees? To my prototype, Scott. All right. 20 minutes goes by. Nitish, being a nice guy, comes to me and says, here's your $2 back. What am I going to do with it? Put it in my pocket, right? Because I gave him the $2. He comes back a few minutes later and says, here is 100 rupees for you. Being such a nice guy, I'll give you more money. I take the 100 rupees, and what do I do with it? Put it in my pocket. You guys understood JavaScript very well. That is exactly what prototypal inheritance is. When an object has a property, it gives it to you. When an object doesn't have a property, it gets it from the prototype. It could go multiple levels to get it. But when you set a property, where do you set it? Always on the object. You never go to the prototype. Do you see why this is such a great idea? Not for him, but why is it such a great idea? Because now we can share the prototypes among multiple objects. Now imagine for a minute, if I modify my prototype, and if you, Venkat, also share the same prototype, we're going to get confused here, right? So as a result, you say prototypes can be shared, gets go to the prototype, but sets are very shallow. So you can share, but they overshadow, giving an illusion of this concept in programming called overriding, right? So you can override and mask objects, and then you can give overriding. And that is exactly how prototypal inheritance really works. So if you want to look at how this is going to work together, we could say var vehicle equals function. And in the case of this function, we can specify maybe the miles. So this dot miles equals 0. So what I'm going to do is I have a car object here. And in this case, in the drive function, I'm going to say this dot. So let's go ahead and ask for miles, right? We'll come back to the drive a little bit later. So we create an object of car. We did. Now what am I going to do? I'm going to say here a car dot prototype equals, and this is going to be the vehicle. So let's go ahead and say new vehicle to set up the vehicle. Now one of the beauties of JavaScript is not only can you have prototypal inheritance at the class level, you can also have prototypal inheritance at the object level. And as a result, you can, look at the beauty of this. In Java, C++, C#, inheritance is static, right? You inherit from a class and you're stuck with it. You can never change it. In the case of JavaScript, inheritance works through prototypal inheritance. Right now, Scott is my prototype. And he has enough money, so it's good to have him as a prototype, right? And later on, as I'm running this code, maybe I'm in a test situation. Or maybe I'm in a different condition where I have to really have a different behavior. Very quietly, I can switch my prototype either permanently or temporarily. And now I have inherited different sets of behavior. And then I can switch back at convenience, right? So this is like you can have rich parents in the weekend and disciplining parents in the weekdays, right? So you can kind of have best of both worlds. It gives you the flexibility to back and forth. So that you can do at instance level as well. But now that I've set this as a vehicle, I'm going to come down to the car and say, hey, car1 dot year, I want to know what year this car was made. And I say, hey, tell me car1 dot miles to ask him for the value of the miles. Notice it was 0. You could write a miles function if you want, drive function if you want to, but miles equals 22. I'm going to set the value for miles at this point, and I want to print the value of miles, and notice it did change it. But where did it change? So if I say var car2 equals new car 2012, another car, and I'm asking this car2 for a value of miles, car2 dot miles, and I want to know what the year was. Let's make this 2011 for a minute. And this is going to be car2 dot year. And in this case, you will notice that the value of miles is still 0, even though we modified it on the car2. Am I making sense? This is the example I gave you where he gives me the money and I keep it. I didn't go give it. So you got a 0 value, first of all, because it came from the prototype. But when you try to set it, it sets it on the object. There is so much more we can talk about in terms of prototype and how we can put it to use. But unfortunately, we're out of time. I hope you found it useful. Thank you.